Okay, we're going to do a problem from section 6.6, finding centers of mass. So in this problem here, it says here, find the centroid bounded by 6 minus x squared and y equals 3 minus 2x. Okay, now what do we mean, of course, by the term centroid? Centroid, of course, means we're going to find x bar comma y bar when the density is constant. That's what this means. Okay, so the first thing we need to do, it doesn't have to be the first thing, but we'd like to get a general idea of what the boundary looks like between 6 minus x squared and 3 minus 2x. So maybe the first thing we may want to do is find what our limits of integration are, find what our boundary limits are. So we're going to set 6 minus x squared equal to 3 minus 2x, and then we're going to solve for this. Solving for this gets us to 0 equals x squared minus 2x minus 3. So 0 equals x minus 3 and x plus 1. So x is equal to 3 and negative 1. Okay, then if we choose a point in between negative 1 and 3, say 0, we can pick 0 in, and we notice that if we put 0 in for x in each of these, y equals 6 minus x squared is indeed the larger function. Okay, but what we can also do, of course, is we can pull up the graph of it. There it is. So I already had this graph pre-done. So this is what the graph of it looks sort of. So I'm going to make an attempt to draw this. So it looks like we have something like this, and then maybe something like this. Actually, it's below the x-axis. So maybe something like, come on. Maybe something like that. Okay, and of course, here is going to be our little rectangle, and in the middle is going to be our x tilde, y tilde. So I want to blow that up a little bit. So here's our rectangle. Or try to be. Here is the center of our rectangle, right in the middle. And this point is x tilde, y tilde. It is the center of our strip. And we're going to add up a whole ton of strips to find what our center of mass is. Okay? All right, so what are we going to do first? Well, let's find x bar first. So we know, hopefully, that x bar is equal to the moment about the y-axis divided by the moment. Okay? The moment of the y-axis is equal to the integral of x tilde times dm. Okay, what is dm? dm is equal to dA. Now notice, normally dm is lambda, or delta d. I said lambda again. dm is usually delta dA, but because delta is constant here, and we know that when we're finding the centers of mass, x bar and y bar, we know that the deltas will cancel. So I'm not even putting it in here. I'm just going to say that the incremental change in mass is equal to the incremental change in area because the densities are constant. Okay, so then how do we get this? Well, what is x tilde? Well, we decide since our rectangle is moving left and right that we're just going to make x tilde equal to x. Okay. Now, if you're doing a problem where this was all in terms of y, where it was x equals values in terms of y, and your rectangle was actually going this direction, okay, then you would let y tilde equal y. But our rectangle is not going in this direction, it's going up and down. But if it's going side to side, y would be y tilde. But since it's going side to side, x is x tilde. That is, it's an top to bottom rectangle that is moving from side to side. Okay, so that means that x tilde would be x. Okay, all right, so let's move on. What is dA? In other words, what is this area here? Well, the area, of course, dA is just basically the width times the height. Okay, now the width is going to be dx. Okay, because we're going to use an infinite number of rectangles. So the rectangles, or the strips in this case, are going to get smaller and smaller. It changes. Okay, the height, though, will always be the top function, this function, minus the bottom function. The top function minus the bottom function. Okay, so therefore, the height will be equal to the top function, which is 6 minus x squared, minus the bottom function, which is 3 minus 2x. So if you simplify this, this I do believe is negative x squared plus 2x plus 3. Okay, that's the height. So therefore, dA, which is equal to x, negative x squared plus 2x minus 3, all times the change in width, which is dx. And by the way, since dm is equal to dA, this is also equal to dm. Okay. Hopefully you can read that. So that is dm. So therefore, the moment about the y-axis right here is the integral of x tilde dm. X tilde is x. So here we go. So that means my is equal to the integral from negative 1 to 3, since that's where we're going from up here, negative 1 to 3 of x tilde, which is x, times dm, which is dA, which is right here. That's negative x squared plus 2x minus 3 dx. Okay. Now I'm not going to go through the work in finding this. I think you can do that. You can distribute the x and then take these 3 power rule integrals and go from negative 1 to 3. I think you can do that. So I'm not going to go through that process. But if you do it, you will get my to be 32 over 3. And my is done. But we will be going back to it. Okay. The next thing we have to find, we have to scroll back up, is we need to find, here we're using this formula, so we need to find m. Okay, went over there. M is equal to the integral of dm. But dm is down here. Okay, there's dm. So all this is this is just equal to the integral from negative 1 to 3 of dm, which is negative x squared plus 2x minus 3 dx. Okay. So you notice that m, the moments, the moments of the mass is very much like the moments about the y-axis. The only difference is, if you look down here, the only difference is there is an x being multiplied, the x tilde. That's the only difference. Okay, again, I'm not going to do this integral, but if you do it, you will get 32 thirds. Okay, which therefore makes x bar equal to my, the moment about the y-axis, 32 thirds, divided by m, which also is 32 thirds, and we get 1, and the x bar is finished. Okay, now we will do y bar. Okay, y bar is equal to the moment about the x-axis divided by the moment. Okay, the moment of the x-axis is equal to the integral of y tilde dm. So we need to find y tilde. Okay, y tilde, if we go back to our rectangle over here. Now x tilde we just decided by is just x, but y tilde is different. We have to find y tilde, which is halfway up and down in this box. It's halfway between this line and this curve. So halfway would just be the average. So if we add up this curve here and this line here and divide by 2, that's taking the average, then that will get us y tilde. It would be in the middle. So y tilde is the average of 6 minus x squared plus 3 minus 2x, all divided by 2. And if you simplify this down, we won't, well, okay, well, yeah, we'll simplify this down. I was going to do it when we did the integral, but this is fine. Negative x squared minus 2x plus 9 over 2. Okay. Okay, so now what is mx? The moment about the x-axis would equal the integral from negative 1 to 3 of y tilde. We're doing this. That's an equals. Okay, y tilde is all this, but I'm going to yank the 1/2 out front. I think that's easier if we do that. So negative x squared minus 2x plus 9 times, right here, dm. dm we've already done. dm actually is here in yellow. So we'll just copy that in there if I have room. So this is negative x squared plus 2x minus 3. And I got to fit the dx in there. There's the dx. Okay. So that means that mx is equal to 1/2 times the integral of negative 1 to 3. This all has to be multiplied out. And when you do that, you get x to the 4th minus 16x squared plus 12x plus 27 dx. Do the integral, and you get mx to be, and don't forget to divide by 2 or multiply by half. You get 416/15. That's the moment about the x-axis. 416/15. Okay, so now to find y bar is we take 416/15 and we divide that. We're using this formula now. We divide that by m, which we found. Where is m? It's up above. Here is m. m is right here. That's 32/3. So we divide this by 32/3, and if you do this math, you're going to get 13/5. So x bar comma y bar is equal to 1 comma 13/5. And that's finding a centroid. I hope this was helpful. And again, I apologize for my 3rd grade handwriting, but my bamboo is not the best bamboo in the world. The good ones are really expensive. Okay, thanks a lot.